ending our compound lesson, and what you're going to be able to do today, you can solve compound inequalities. So everything's been solved for you prior to today, and you've been graphing or translating it to interval notation. Now you're going to have to solve, and to solve means to get the variable by itself. That's what it always means if I say solve. So you have two different compound situations, your ors and your ands. Both of them, you deal with them a little bit differently to solve. In OR, what you do is solve both inequalities separately. That means it's kind of a bummer because you're solving two equations in one, is really what you're doing. So it's double the work. But it is what it is, you just have to do it. So, given this first one, I have x minus 3 is bigger than negative 2, or x minus 9 is less than negative 20. I cannot graph this because the x's are not alone. So I need to solve both of them. So I'm going to plus 3 to my inequality on the left side of the OR, and you get x is bigger than 1, or now I have my other inequality I have to solve for. What do I need to do to solve for this one?
Add 9.
I sure do need to add 9. So plus 9 to both sides of the inequality. And I get x is less than, what would that be, negative 11? Because you actually subtract them. And there is my actual OR compound. So notice what I did, I just figured out my left side and my right side is what I did. Figure out that one, get the variable alone, you're done. Okay, guess what you gotta do sometimes? You gotta flip that inequality. Hope you didn't forget about that. Remember, if you multiply or divide by a negative number, you must flip the inequality because it created a false statement. So this first side, I'm going to times through by negative 3, times through by negative 3. That cancels, and I get x. Now watch what I'm doing. X is less than positive 6. Okay, I flipped. Maybe even write that on the side. Flip. Why did I flip? I'll show you why I flipped the negative 3. I'm multiplying by a negative, so I had to flip it to keep it true. I had to M, D, and F it. Okay, my next one, plus 12, and you get x is bigger than 13. And those are my two, that is my compound inequalities. Okay, got it? So the ORs, you just do two separate, you have to solve both of them separately, and then you would graph it eventually if needed. The ANDs is a little bit different. What I need you to visualize here, remember algebra is all about balance, and so what you do to one side of an inequality or an equation, you must do to the other. But how many sides are on an AND? One side, two sides, 3 parts. Do you see how an AND has 3 parts to it? You have a left, you have a middle, you have a right. So what you do to the middle, you have to do to the left and right to maintain that balance that algebra makes you have. So just watch. So what is by the x right now? In the same section as the x? The negative 5, right? So what I need to do is move that minus 5. So I'm going to plus 5 to get rid of it. However, now I'm not balanced. If I plus 5 to the middle, I need to plus 5 to the left, and I need to plus 5 to the right. You see what I did there? It's different than anything you've ever done your whole entire life. Because usually what we do is only two sides. But an AND has 3 parts, a left, a middle, a right. Then I get 3 is smaller than x, which is smaller than 12. You feel okay with that? So you have to do it to 3 parts for an and. Okay? Okay, multi-step. What do I need to move first on this bottom one? Say the 3.
The
Do you see why though? Because it's not connected. You always move what's not sticking to it, and then you move what is sticking to it. So I'm going to add 3. I'm going to add 3. I'm going to add 3. Do you see how I did to the 3 parts? And then I have 8 is smaller than 2x, which is smaller than 11. Now what do I need to move? What's by the x? The 2. So this is 2 times x. The inverse would be to divide. Do it to all sides to maintain that equality. And you get 4 is smaller than x, which is smaller than 5.5 or 11 halves, however you want to write it. 11 over 2. Maybe you like 5.5 better, but it's okay if it's a fraction. I know I did my algebra right, so it's totally fine. So, you got to solve today. You got to be able, given a graph, you need to be able, or given a compound where the variable's not by itself, you've got to isolate it. Going with that, you have fractions. And I like fractions, and we've been doing fractions in Unit 2. And part of Unit 3, I don't remember. But the first thing you want to do is get rid of that denominator. It will make your life so much easier. That's always the first thing you want to do is get rid of that denominator. How? I'll tell you how. You multiply. So to get rid of a denominator, you multiply through and it will cancel it out. And then you solve. Oh. So get rid of the denom and then solve it. All right, here I go. So I'll just do one example for both so I don't waste your time too much on this. Okay, so I have my ORs. Remember, ORs you have to solve 2 separate OR statements. So I have 2x over 3 is smaller than 2. The first thing I'm going to do is get rid of that 3, so I'm going to times both sides by 3. Cancels out the denominator, and I have 2x is smaller than 6. And then you divide through by that 2, and you get x is smaller than 3. Or, now I'm going to solve my other one. Bless you. Times through by 4. Remember my purpose. I'm trying to get rid of that denominator because I don't love it very much. It's stressing me out, so I'm getting rid of it. And I have 3x is bigger than 24. Divide through by the 3, and you get x is bigger than 8. And there is my OR statement. Okay? So again, all I do is get rid of that denominator by timesing both sides through. And be cautious of flipping. Sometimes you have to flip, and I'm being forgetful of that here. So I want you to remember that sometimes today you might have to flip that inequality. An and example. Well, I got to look at the middle. That's where my variable is. So what I want gone is the 3 and the 5. So I'm going to slowly work my way to get rid of that 3 and 5. So the first thing, times everything. Now there's 3 sides. Times everything through by 5. Do you see how I did that? I have to do left, middle, right. So this is negative 15 is smaller than 3x, which is smaller than 10. And now I can move my 3 by dividing. So I got divide by 3 to 3 parts, because there's 3 parts to an and, left, middle, right. And you get negative 5. You didn't have to flip it, because I'm dividing by a positive. So no flipping that one. Negative 5 is smaller than x, which is smaller than 10/3. And that's how you solve. So, same strategy as before. The only difference is ands. You have to do things to 3 parts.